All right, so on this first one, we're given a graph, and we're asked to find some different features about that graph. The first thing I'm going to do is go ahead and draw in my midline to this graph. And so I can see that my midline is at y equals 1. And then from that midline, I can look to see where it goes up and down from that midline. So the amplitude would be the distance from the midline to the maximum or from the midline to the minimum. So that distance I can see is 2. The next thing, the period. So the period will be the distance from where it hits the midline to where it hits where it completes the whole period. Or I could do like from max to max or min to min. So I can see on this one that it starts repeating after 2 pi radians. And then the next one is the vertical shift. So I can see that my midline has moved up 1. So the vertical shift is 1 unit up. And so then I can write down my equation. So if I look at this function, if I start here and I look at this looks like a sine function that has been flipped over. So it's going to be negative, the amplitude is 2, sine of, and my theta, my period has not changed, so it's just x, and then plus 1 for that vertical shift. All right, for the function, that one, find the amplitude and the midline. In addition, find the domain and range. So the amplitude is right here. So the amplitude is the absolute value of that number in front, is 4.2. And the midline is going to be related to this vertical shift. And then it says, find the domain and range of f. And so, since this is a sine function, the domain will be all real numbers. So negative infinity to infinity. And the range, I want to do the highest y value and the lowest y value. So I'm going to draw this out. So I know that it shifts up by 1.1. And then from that 1.1, it's going to go up an additional 4.2. So 1.1 plus 4.2. And then from there, it's going to go down 1.1 minus 4.2. So the smallest value, if I do 1.1 minus 4.2, would be negative 3.1. And it is actually going to hit that value at those minimum values. And then it will go up to 1.1 plus 4.2, which is 5.3. So there is my range. Number 12, it says the hottest day had a high of 103 and a low of 69. The temperature throughout the day can be modeled by a sine or cosine graph. And so we can figure out what all of these values are. So I'm going to start by labeling on my graph. The lowest value was 69 degrees, and the highest value was 103. So from that, I can find my midline. It'll be halfway in between. So to find my midline, I'm going to take my max, 103, plus my min, 69, and divide by 2. That's going to average the two numbers. It's going to find the number that's exactly in the middle. So if I do that, 103 plus 69, and then I divide by 2, I get 86. So that is my vertical shift. So 86. So that means my value of k is 86. My period for this is a 24-hour period. So the period is 24. And I know that the period is related to the b in that the period is equal to whatever the regular period is divided by b. So for a sine function, the regular period is 2 pi over that b is 24. So if I reduce that, I get pi over 12. And then the value, the amplitude would be the distance between the midline and the maximum. So if I do 103 minus 86, that gives me 17 is my amplitude. And now I need to figure out, if I look at this function, I'm just going to trace it here. It looks like a cosine function because it starts at a minimum and it goes up to a maximum and back down to a minimum. That's a cosine function that's been flipped over. So the value of a is actually negative 17 because there is a flip over from that cosine function. So there's no horizontal shift. And so we have y equals, excuse me, negative 17 cosine of, the b then is pi over 12, x plus the k is 86. Okay, so one thing we know about the tangent of an angle is that the tangent of this angle, pi over 3 here, is going to give me the slope of that line. It gives me the y over the x. So I can find the slope, m, by doing tangent of pi over 3. And if you go back to your unit circle, the tangent of pi over 3 ends up being the square root of 3. And then we can find the b. So this problem asks for a lot of things. It asks for an exact value of the slope, m, which I just found. The next thing it asks for is the exact value of the y-intercept b. So to find that, I can take y minus y1 equals m times x minus x1. And this is the, that is the point slope form of a line. So I can plug in my slope and my point. So I have y minus 6 equals square root of 3, x minus 5. And from that, I can solve for y. So y equals square root of 3x minus 3 square root of 5, and then plus 6. Oh, excuse me, 5 square root of 3, not 3 square root of 5. I don't know why I switched those. So 5 square root of 3 plus 6. And so this number here is my b. So b equals negative 5 square root of 3 plus 6. So I found the m, I found the b, and then here I also have the next thing it asks for is the equation of the line. And so the equation of the line is here. So I've written the equation of the line there. And then the next thing it wants, the equation of the line with the parameters rounded to 2 decimal places. So it's going to be y, oh, sorry, I'm still on the highlighter. So it's going to be y equals, and then the square root of 3 in decimals. It's 1.73. And then if I do negative 5 square root of 3 plus 6, that gives me minus 2.66. And so there it is with the parameters rounded. Oops, sorry, I was trying to highlight that. The parameters rounded to 2 decimal places would be this answer there. All right, so the next one, given the tangent function passes through those points with asymptotes as shown in the figure, describe exactly how this graph is related to y equals tangent t, and then find a possible formula. Okay, so what I can see here is I can see that there is a few things going on. So one thing is I'm looking at where these asymptotes are occurring. And I know that the standard tangent function has asymptotes at pi over 2 and negative pi over 2. But this one has asymptotes at pi over 4 and negative pi over 4. So that means that this graph has been squished vertically or horizontally by a factor of 2. So we can say that that there is a horizontal compression by a factor of 2. So the next thing I'm noticing is that this point here in the middle of where it crosses the midline and where this asymptote is, usually is up 1 unit, but here it goes up 6 units. So what that means is that I have a vertical stretch by a factor of 6. And so if I put those together, and I also notice that the middle, where it goes through the midline, actually happens at 0, 0. So that means that there is no up and down translation. So no shift up, down, or left, right. And there's no flip. So it's it's increasing like this. So there's no flip. All right, so I think I'm ready to write it out. So f of t is equal to 6 is my vertical stretch, tangent of, it's going to be 2x. So 2x. And that's that one. Okay, next, sketch the graph of a transformed function, tangent function, with vertical asymptotes at every odd integer and passing through those points. Use your graph to find a possible formula. Okay, so let's make a graph. So negative 1. It has asymptotes like this. I'm just going to focus in on the middle part of it. And it goes through the point 0, 1, and the point 1/2, -3. So that's here. And so when I sketch this out, it's going to like this. Okay, and so I want to find a possible formula for that guy. And so what I see is that the period of this is 2. And I also know that the period is equal to the regular period, which is pi for tangent, over b. And so from that I can solve for b. So I could set 2 equal to pi over b, multiply both sides by b, divide both sides by 2. I get b is equal to pi over 2. So that's my b right here. For the a, I want to find out what the vertical stretch is. So I'm going to start at this this is kind of like the midline, right? It was shifted up, and then from there down to here, I can see that I have gone 4 units, and there is a flip. So that means that my a is equal to -4. And then for the k, that would be my shift up and down, and I have shifted my middle of my function up 1 unit, so that my k is equal to 1. And so now I can write out my function. So I have f of t is equal to -4 tangent of pi over 2t plus 1. So there's my final answer there.